communications. So let me first thank you 6G Alliance and in particular Pathak Sahab for starting the Tech Talk series. Every fortnight, I had said, will be some or other talk on 6G and other technology. So thank you for doing that, and it will be really beneficial for all the stakeholders. And also, I would like to congratulate you on the first anniversary of 6G Alliance. So congratulations to entire 6G Alliance team, and in fact, congratulations to all of you, because I mean we all feel part of it, and let's see that we bring 6G in our country and also we export to the world. So with this, let me upload my PPT. Give me a moment. So please confirm if the PPT is visible. Anyone?
Yes, sir. It is visible, sir.
So thank you. So as topic given to me is ITU Vision and Framework for IMT 2030. So let me begin straight away. So let me first take a pointer. Let me first tell you that every generation of mobile communications, so it takes almost 10 years to evolve from one generation of mobile to the next generation of the mobile. And on the same line, like ITU, that 6G will also take almost 10 years till it is commercially launched. So the journey started in 2021. You can see the timeline on the screen. So journey started on 2021 when ITU started working on creating framework and vision for 6G. So it's a 2 years process. You can see on your screen that initially ITU issues of future technology trends. So with the help of experts, what are different technologies which are trending or will become a commercial thing in future. So those are discussed and a report is taken out. And then it also issues the framework and vision which is required. In addition, ITU is also working on feasibility of using IMT, that is mobile communications, beyond 100 gigahertz of the spectrum. So this is the first part of the framework and vision which is now done with. The next stage is about creating technical performance requirement of 6G radio and how that performance requirement would be evaluated once 3GPP and other SDOs are able to build the specification and standard. So this is also a almost 2 years period. After 2026 onwards, parallelly 3GPP and other SDO would be working in developing the standard, and maybe around 2027, 2028, the 3GPP and maybe some other SDO would come back to ITU and submit their technology for 6G, which ITU evaluates and declare that as a 6G technology, or IMT 2030 they call. So ITU terminology for 6G is IMT 2030. So we can see the first phase of deployment of 6G maybe around 2029 and 2030 by the time the standards are also published by ITU, and 3GPP standards are parallelly, vendors are actually working to also create the commercial system. So by 2030, we can see some commercial rollout of 6G system. So it's a 4-step process: framework, requirement, then evaluation and fixation of specification, final approval, and the launch. So the first part, the vision and framework, which ITU has already published, I'll be talking about that. So it starts with creating some usage scenarios. So based on different stakeholders, all the 193 plus country and other members of ITU have decided that what usage scenarios 6G would be handling. So if you look at this, they have decided, or they have, through the process of consensus, decided that 6G would generally have 6 usage scenario. Out of the 6 usage scenario, 3 are extension from 5G, that is IMT 2020. So in 5G, we had enhanced mobile broadband. Now that will be expanded as immersive communication. 5G had massive machine type communications. Now it will be called massive communication in 5G. Uh, Ultra reliable low latency communication in 5G is now will be enhanced to hyper reliable and low latency communications. So in addition to these three usage scenario extended from 5G, there will be three new usage scenario in 6G, and they are ubiquitous connectivity. This was in fact pushed by India. So we at ITU pushed this particular requirement to be part of the usage scenario. The next two are integrated AI in communications. That means we are talking about having native AI functionality onto the 6G network. And then we are talking about the sixth user scenario as integrated sensing and communications. So sensing traditionally has been a separate vertical or separate entity. Now we will try to converge communication and sensing together with this particular usage scenario. On the top of this six usage scenario, ITU has also decided to have four overarching aspect. When we say overarching aspect, we are saying that there will be a design principle applicable to all these six usage scenario. They are sustainability, connecting the unconnected, ubiquitous intelligence. So intelligence should reach to everyone, not only urban population, but even the rural population. And finally, security, privacy, and resilience. These four overarching aspects would apply to all the six usage scenario. Now let's talk about these usage scenario and the capability required to support these usage scenarios. So if you look at this palette diagram given by ITU, it talks about six enhanced capability of 5G. So in terms of peak data rate, user experience data rate, spectral efficiency, area traffic capacity, connection density, mobility, latency, reliability, and security, privacy, and resilience. So these were already part of 5G. So these capabilities are in fact enhanced for 6G. The target given are enhanced target. In addition to meet the three new usage scenario, the six new capabilities has also been talked about, and they are kind of a coverage to meet ubiquitous connectivity, sensing related capabilities, AI related capabilities. Sustainability has come as one of the capability, interoperability, and the positioning, which is very, very important. So let us talk about each of these capabilities in detail and what kind of usage scenario they will be supporting. So starting with immersive communications. So for immersive communications, what are different capability which may be required? So let's start with peak data rate. So peak data rate is something which will be very important for immersive communications. And as we know, in 5G, ITU has had defined 20 Gbps downlink peak data rate, whereas for 6G, these are targets for 6G, not the actual requirement. Actual requirement will come maybe next year sometime. So the target this time is a staggered one. It's not a one absolute value. So they have said 50 Gbps, 100 Gbps, and 200 Gbps. So that means they will go 10 times from 20 Gbps to 200 Gbps, maybe in a staggered timing in different releases they will talk about. The other important parameter for immersive communications can be user experience data rate. And as we know that for 5G user experience data rate, so data rate which should be available across the coverage area, maybe even at the edge of a coverage. So that was 100 Mbps for 5G. For 6G, target is 300 Mbps, and it can move up to 500 Mbps. That means it will go 5 times better compared to 5G. In respect of spectral efficiency, that in 1 hertz of the frequency, how much data rate one should be able to achieve. So the target here is 45 bit per second per hertz, and it will go up to 90 bit per second per hertz, which is 3 times better than 5G. 5G it was 30 bit per second per hertz. So in every aspect there is enhancement. Area traffic capacity, which was 10 megabit per second per square meter, whereas for 6G the target is go to 30 and then to 50 megabit per second per square meter. uh, Mobility, so mobility is something when we travel in our car or in a train or in a bullet train, our mobile should actually work. So mobility up to certain speed only technology supports. For example, 4G supports a mobility of 350 kilometer per hour, and 5G the target was 500 kilometer per hour. In 6G we are talking about that 6G phones should actually work even in a vehicle which is running at 1,000 kilometer per hour. It's a very huge enhancement, and that will really help roll out mobile services in a moving kind of environment. So these were kind of a capability which would be supporting immersive communications. Now let's look at different capability which is required for supporting massive communications. So starting with connection density. So when we say connection density, what it means is that in a per square kilometer, how many say IoT sensors, other objects or machine can connect to the network. So that's a requirement coming up, because in future we see that every object, every machine, everything would get connected to say network. So the connection density supported in 5G was defined as 1 million or 10 lakh devices per square kilometer. In 6G want to go up to 10 crore devices per square kilometer. It's a very huge research target which has ITU has given in its vision document, and let's see what exact number is defined in the requirement document next year. To support hyper reliable low latency communication, that is HRLLC, the first requirement is on latency. As we know that 5G, we are talking about 1 millisecond latency for URLLC type of requirement, whereas in 6G, the target is to go up to zero point 0.1 millisecond, 10 times better compared to 5G. That's the target given to study and include in the requirement document. And the reliability. So reliability is measured in terms of say packet error rate. So when I transmit some data to you, how much data you are able to receive correctly and how much is the error. So in case of 5G, we have seen that 3GPP standard, if you look at, they have talked about 10 to the power minus 6 also in some of the URLC applications. So that means only one bit of error in 10 lakh bit transmitted. In 6G, we are talking about 10 to the power minus 7. If you translate that into percentage, it comes to 99.99999. That is kind of a 7-9 kind of a reliability we are talking about in terms of packet error rate and also in terms of availability. That's the reliability which is required for HRLLC kind of applications we are talking about. And then positioning is also very important requirement coming up to the mobile. Till now we had been majorly focusing on GPS technologies, but GPS technologies have limitations. It doesn't work inside a environment unless satellites are visible. You don't have good positioning system, but 6G or even 5G advanced can do some sort of positioning. So here target given is up to 1 centimeter accuracy 6G to support. So the next, the fourth usage scenario, we talked about ubiquitous connectivity. For ubiquitous connectivity, coverage is the requirement, technical requirement given. As we know that India had developed its own 5G technology called 5GI, mainly to meet large coverage, where we had proposed pi by 2 kind of a modulation and some other techniques. So 6G also, this requirement has come as a ITU requirement. Maybe our industry, our academia would be pushing certain technology for India so that we have a larger coverage from the cell, so that services are available to more and more remote and rural customers. For integrated sensing and communications, so the requirement which ITU is talking about, that we should be able to judge range or velocity of a particular object or angle estimation, detect an object, we localize those objects, imaging, mapping, all those sensing capability which was a separate vertical earlier. Now it will converge into mobile communication itself to some extent, or maybe going forward to a large within the 6G network. Can we have distributed data processing? In fact, we already have edge computing in 5G, so those are becoming a possibility. Distributed learning, AI computing, AI model execution, AI model inference, and all the technique which we have in AI, can we like have natively available into the 6G network? So that's the target which we have today. In terms of interoperability, what ITU has talked about, that from different technologies, different radio technology, they should talk to each other today. Although we have kind of a XN interface or X2 interface in 4G and 5G, but practically those are not working between different vendor. So can we have that interoperability as a one of the important requirement of 6G, so that interoperability aspects are taken care of. Now, finally coming to the design principle, as we talked, that all those 6 usage scenario in this wheel diagram is now covered by those design principle, which are kind of a sustainability, connecting the unconnected, ubiquitous intelligence, security, privacy, and resilience. So ITU has talked about security, which are traditionally confidentiality, integrity, and availability. How we can build that? These are already there in 4G and 5G. How we can better enhance? And today, one of the aspects is how we can make these quantum safe. Would be some of the things which we should think of. Then privacy. So protection of individual personal information or personal privacy is one of the requirement or overarching principle which should apply to all the 6 usage scenario. The second point in privacy is very important, that in case my data is used, for what purpose it is being used, when it is being used, I should be informed. So that means my data can only be used with my consent, right? So that's a very important aspect which is coming onto the design principle of mobile communications. That's very good that we will actually cater to all the privacy need. And of course, the resilience. Resilience is very important in case of any man-made disaster or maybe natural disaster. Our network should continue to work. For example, if there is a loss of primary source of power, we should have enough arrangement of secondary sources that communications continue. So resilience is also one of the overarching or design principle of 5G. In respect of sustainability, we are talking about how we can build the 6G network, which is very, very energy efficient. Although 5G is supposed to be much more energy efficient than 6G. In 6G, we are talking about having completely green kind of technology, how we can minimize energy consumption and use the minimum of the resources. So those are the sustainability aspects we have to take care of. So with these usage scenario and the capability of 6G, which ITU has talked about, so what kind of new services we are looking for in 6G and beyond, so that some of the actual use cases can be holographic communications. That means mobile based holographic communications. I can take holographic communication to my office, to my home, wherever I go. Tactile and haptic internet applications, mainly for industry and other use cases. The convergence of compute and network. So today we are talking about edge computing. So can we have computing and network convergence, which has already started in 5G, that will consolidate. How we can have very high data rate access, connecting everything, connectivity for everything, so that ubiquitous coverage thing. And then vehicle to vehicle, vehicle to infrastructure communications, extended reality, multi-dimensional sensing, digital twin, machine type communication, proliferation of intelligence, and seamless coverage, global seamless coverage. So these are kind of a new area. So what are different opportunity for us, what are different opportunity for India, and of course for the world. We are already working, but let us talk about that. First of all, what could be different technologies to make 6G network AI native? What can be different technology wherein I can have integrated sensing and communications? These are basically research area where our industry would be working, our academia would be working and contributing to 3GPP to include our IPR, our SEP. Technology to support convergence of communication and compute. What are different technology for device to device communications? We are already doing in 5G and 5G advanced. How we can utilize the spectrum very efficiently. Somebody is talking about a blockchain based spectrum sharing and all. How we can have energy efficiency concept, how low power consumption, particularly in IoT devices, would be possible. How we can support natively real time services and communications. So technology for that, technology for trustworthiness, that is security part of it. What enhancement radio interface need, whether you want to reuse the same OFDM waveform, you want to bring in some new waveform for 6G, what could be modulation technique we'll be using, what kind of different antenna or advanced antenna we have, talking about cell-free massive MIMO, whether that will become part of 6G, what technology India can bring onto that. We are talking about full duplex in a TDD environment, in band kind of a full duplex. So, what kind of technology we can develop onto that, and so on. So there are many things. One of the buzzword today is the terahertz communications, and we are supporting terahertz communication research and product development from DOT side, as you know. So whether we can develop or create our own transmitter and receiver in terahertz, what kind of use cases we can create using the terahertz technologies. Then technologies for accurate positioning. So these are all kind of a area of research which you can see here: RAN slicing, maybe digital twin. One of the important is integration of non-terrestrial network. That means how a satellite communications can become part of our mobile communication. There can be a seamless roaming between terrestrial and satellite and so on, so that we are able to cover unconnected area. So these are kind of research area where our researcher can develop the technology, develop the product, and put it into the 3GPP standard, and we put our own IPR and SAP out there. So thank you. That's the end of my slide. In case you have any question, or maybe I hand it over to Asta for further anchoring it.